I'd like to demonstrate ECOS and the Indi libraries for people who are interested in astronomy and using an alternative method of telescope control using Linux. And this demo is strictly going to be a step through of ECOS. We're going to start off with bringing up the system and doing a polar alignment, and from there we'll go on to other aspects of the program. So the first step I'm going to do is the telescope's already set up outside and it's been turned on. I haven't done a polar alignment yet, so that will be one of the steps coming up. So the first thing I want to do is I want to bring up the desktop planetarium program called Kstars. Now Kstars interfaces with ECOS. Some of you who are into Linux might be aware of this program. It's a nice program. It gives you a planetarium effect of some of the other astronomy programs in Linux, such as Stellarium. But the unique thing about Kstars is it interfaces with the Indi libraries, and it allows you to control a complete observatory if you so desire. So we brought up Kstars, and the next step would be to bring up ECOS under Tools. So we'll click on ECOS and bring our tools, and then click on ECOS. From there you'll see that I have a screen that starts off, and I've already predefined a profile, and this is my profile. It's for the William Optics 73mm Zenithstar telescope, along with the EQ45 Pro mount. If I do click on to edit the profile, you'll see that the following configurations or devices are configured for the system. Here's the profile name. You can see that I'm using internal guiding. There is a web interface to manage the device drivers, and I'll show you that in just a second. You'll have the mount definitions, the CCD definition, the guider camera definition, and I also have a smart focuser. And in reality, it's not truly a smart focuser. It is an Arduino focuser of my design. And then finally we have the filter wheel, ASI filter wheel, that is defined here. So if I click on the web manager, you'll see that a page has come up with the Indi web manager. And right now it's under simulators, but normally it'll default to the current configuration, and it already has, really. I was doing some testing earlier and I didn't completely set it back up to where it should be. So if I go under the equipment profile and use my equipment profile, you'll see that it'll auto start and auto connect. We're going to go ahead and stop the current drivers, which you'll see the server status that shows offline and there's no device drivers loaded. If I hit start, you'll see that the device drivers are re-added to the server's processes. We don't need this anymore. I just wanted to show you the unique Indi web manager for managing your devices. And this is nice when you have multiple configurations that you might have. For instance, I have an Astrograph 8-inch that I also have a configuration and equipment profile for. So I'm going to block this out. This looks good. We're going to go ahead and save. And then we're to start ECOS. You'll see that the devices will start to come up under the Indi control panel. Here's the main CCD or camera, or actually it's a CMOS camera. It's a ASI 533. If I click in the tab for the Ioptron EQ45 Pro, you'll see that it's connected and online. Gives you the current coordinates. Here's the filter wheel configuration. You'll see that it's connected. And the filters, you could configure the filter wheel for many different ways. I was using a monochrome camera and had, the normal red, green, blue filters. Right now it has also an HA filter, so I left it in line with the current camera. Smart focus, this is a smart focuser here. And then finally the guide camera. One thing that I have noticed with this particular model guide camera is that the QHY gain control always seems to be defaulting to 1. So I'm going to bump this up. And I believe you could set it up in the menus too, but I'm just going to increase the gain while I'm here. There, let's close this out. What I'm going to do next is we have the device drivers loaded. Everything looks normal. The telescope currently is in the park position. So we're going to go to the alignment process for ECOS. If I click on the alignment tab icon, you'll see that there is an astrometric function built into ECOS that allows you to download the image and compare the image to determine where your telescope is actually pointed to in the night sky. I have downloaded on the desktop the astrometric files, so that's what it's referencing right now, and this is why this tab is set for offline. If you're interested in more information regarding the use of this, we could go into further detail, but again, this is just a quick demonstration of the capabilities. So I'll go into polar alignment, and what I normally do is, well, let's just go ahead and do this. Everything should be online. The dew caps are off, and we should be ready to go. So a little bit before I hit the start button, this desktop is also tied into a VNC server, and the VNC server is running, and this allows me to use my Android phone using a VNC viewer to display the desktop. So when it comes time to go out and to adjust the azimuth and elevation of the telescope, I could bring my phone and essentially look at the phone as I adjust the mount to center it into the target area. So I'll show you what I mean by the park position is already set up, so I'm going to hit start. By the way, we probably always, I am using the guide scope and the guide camera to do this. Most setups might not have the necessary field of view to use your primary camera to do this. The ASI 533 in combination with the William Optics 73 has the necessary field of view, but I'm going to go and use the guide scope because I think most people would be doing that. So what it's done is it's captured the first image, it's solved for the first image, and now what it's doing is it's going to the first rotation. Okay, now it's capturing the second image. This is all real time, and now it's executing the second mount rotation. And each time it rotates the mount 30 degrees, and it's doing the final image capturing for the third image. Again, it's solving, and here is the result. And as you can see here, let me bring this down and make this a little bit bigger. We're a little bit off. It doesn't surprise me because I always take the mount off on the pier and then put it back, and there's always a slight change whenever I put the telescope back on the pier. What you want to do is you want to select a star that you could follow and move to the field of view, and I'm going to use this bright star here, and I'm going to click on it. And what it does is it creates a target over here, and this is where I need to adjust the mount to. So the next step, I'm going to just bring this up. So the next step, I'm going to hit next, because we are going to set the telescope or the guide to continuously refresh and capture an image. And then during this time, I will be adjusting the mount. So what I'm going to do is I'm going to go ahead outside, hit the refresh, and adjust the mount using my Android phone as the display. So I'll be right back, and you'll see the star move into the target. Okay, once that's done, I'll go ahead and hit done, and what it'll do is it'll automatically repark the telescope into a predefined park position. Once that's done, you'll see that the start lights up again, and I'm going to do this one more time. I always usually do it twice, so I'm going to go ahead and hit start, and we'll go through the process one more time. Okay, there's the first image, which has been processed, and it's rotating. Now it's going to capture the image again. What's nice is you can see what's going on through the log file down here. And as you can see here, it's waiting for the mount to rotate into the next position. What I like about this process is there's no additional cameras, there's no additional polar scopes. And it seems pretty fast, and you can see it's a little off. I think I was a little off the first time, so I'm just going to go ahead and do this one more time just to get it into a little bit better position. I'm going to make it bigger here to make it a little more clear. Then I'm going to hit next and refresh, and I'll be back in a minute as I adjust it again. Okay, that's pretty good. So I'm going to go ahead and hit done. It'll repark the telescope. Now, as I'm going through the menus here, I know it's a bit overwhelming at first when you use ECOS, but you will get used to the different menus. What I'm going to do now is I'm going to hit select solution results, and then go back to slew to target, and I'm just going to leave this, and I'm also going to be changing the main camera as well as the main telescope. And I do this after I do the alignment so that when it's time to skew to a target, everything will be set up. Well, I'm going to pause here right now and then we'll continue later. I noticed that there is some clouds coming in and they should be leaving soon. So I'm going to put this on pause and I'll continue in a little bit. Okay, the next step after we've finished and completed polar alignment is to move the telescope and essentially sync to a target. Before we could do that, however, we need to go into the mount control, unpark the telescope, because remember, after it does a polar alignment, it will park the telescope. So we need to unpark the telescope and start the tracking. If you're using a German equatorial mount, make sure the flip FHA. Make sure that's checked because that will flip the meridian automatically. Alright, so now that we've got the mount turned on, we're going to go and take a look at the star chart here. And I'm just going to move it over to Draco and select a random star in Draco. Right click and say under the Ioptron EQ45 Pro, say Go To. What that will do is it'll move the telescope over to that location, and then what we need to do is bring back the astrometric menu, or the control for the solve control. And this isn't it, of course. This is it. And what we want to do is we want to make sure we slew the target. And all we need to do, and I changed it to primary scope and to the CCD main camera. So we press solve and capture. What that will do is it'll start the process. It'll capture an image. And let me bring this down so you can see the image here. And essentially it solves for that and moves it into the center within an accuracy of arc seconds. Now we could click on the show crosshair and you can see that it matches the target. So essentially we have centered that target automatically and it's tracking. Next thing I like to do is to move it a little bit off target for some fainter stars. So let's go back into our star chart, and I'm just going to randomly just kind of pick off to some area and slew the telescope over there. And the reason why I do that is it's just easier to do the focusing, which is the next step. So what we're going to do now is bring back here and go into focusing. First I'm going to go ahead and turn off the target. We don't need to do that. Next thing I'm going to do is go into this magnifier, which is focus. Make sure that the camera is selected correctly. We're not using any filters, we're using the luminosity filter. This is how you set the exposure time. I'm going to bump that up. Maybe I won't. It should be okay. And really all we need to do now is to autofocus. And what it'll do is it'll determine the HFR of the star and go through the motions of moving the focuser back and forth and determining which is the sharpest focus for the number of stars. Now remember, this is just a quick demo. We could go into the mechanics of this, what it's doing at a later time. Essentially I've already set all this stuff up and it's a solid, it works solidly. So it's still it's still trying to move the scope back and forth, and it's getting it should be getting closer as it progresses. It shouldn't be too far off from the last time I focused the scope. Every time I turn on the scope, the focuser resets it to the count 819. So it's done 8 iterations of focus. It's determined that the steps that were absolute steps were 816. So we're done with that. I think this is a long enough video for part 1. I'll continue this demo in part 2, where we'll learn to set up the exposure and targeting of an object. I want to thank you for watching this video. It's one of the first videos I've ever done, so I apologize for being nervous or having problems talking to you guys, but I am looking forward to making some further ECOS videos that might help people with using the ECOS Kstars library combination. Anyway, that's it for now. Thank you.